something known as the remainder and factor theorems. So first of all, real quick, let's go ahead and look up here on the board. And if I gave you that problem today at the start of class and I said, hey, I'm going to give you 5 bonus points if you get this correct. I want you to go ahead and do that, okay, and see what you come up with. If you don't know what to do, try something, okay? So if I just gave you that problem, what do you think you should do?
I bet it's wrong, and that's why I'm trying to prove a point.
You didn't ask me to get you one. No. You're making fun of me individuals. Hey, why is it?
Alexa Dawson does it. She was like really cool in my
Hey, let's go. Get this done.
Yeah. Don't think that's right, but what else? Oh yeah, 662. That's alright, isn't it? That's cool. Just tell us to do something. No, we're wrong. Just to watch us fail and see if I can.
So did try to talk to you about the math at the concession stand?
Alrighty, so I heard some numbers. What did some of you get? 662. Okay.
Wrong.
How'd you get 662? I'm just curious.
Plugged in 4 for all the X's.
Plugged in 4 for all the X's. So the important thing we remember when we plug in 4 here is that we do the power first, because that's order of operations, the PEMDAS. So you should have taken 4 to the 4th and then times 3. Okay? 4 cubed and then times 2. And then 5 times 4 and then plus 2, and then you add them all together. And you should have gotten 662.
Sweet.
So today what we're going to do is we're going to look at another way that we can find this exact same solution, except for we're not going to plug it into the function. We're going to use something known as synthetic substitution.
This sounds very long and painful.
Okay? So as you think about synthetic substitution, I want you to think back to things we've learned previously. What does that sound like? Or what does that resemble? Something that we've done in the past. Synthetic substitution. Synthetic division. Okay, synthetic substitution is exactly the same thing as synthetic division, except for now what we're doing is we're actually just using a number here. And so instead of when we divide it by like x plus 2, x minus 1, things like that, we're just now going to use this number 4. So if you remember with synthetic division, I started with the number and I put it to the left. And then what would I put in this line here at the top? I would put the equation, kind of the coefficients. So in this case, I'm going to put 3. I'm going to put negative 2. I'm going to put 0, 5, and 2. Why did I put a 0 in? There is no x squared. Okay, there is no x squared here. So one of the things you always need to do is you always need to insert 0 as a placeholder. All right, and this is another check. If 4 is your highest power, you're always going to have 1 more for your number of terms. So if 4 is your highest power, you're going to have 5 terms. If 5 would be your highest power, you're going to have 6. Nice job. So let's go ahead and look. Do we remember what we do first?
Nope.
Bring down the 3. Okay, you always bring down the very first number. Now what do I do with the 3? I take it times 4 and I get 12. Then I do what? Add down. And then what do I do? 10 times 4 is 40. And then I get 40. And then I take 40 times what? 4. And I get, and then I get 165. What is 165 times 4, folks?
660.
660. And then when I add those down, I get, and what did we know that the answer was?
That's
That's
insane.
impressive.
662. So this is another way to evaluate a function.
Are they all this easy?
Okay? That's another way to evaluate a function. So real quick with that in mind, I want you to use synthetic substitution to solve that problem.
No problem.
Okay? So I want you to go ahead and use synthetic substitution, that process we just looked at, solve this problem. Make sure you're paying attention as you write those terms down. Now hopefully you're not getting a number in the hundreds.
I did it. There's no
Unless you've got the X in the fourth. Between 4 and the 2.
What'd you get?
So, yeah.
Okay, I'm going to go ahead and work out this problem. You can go ahead and compare what you get to what I get. Okay, so real quick,
Oh!
hopefully you can see where you went wrong. There might have been a sign that was different. Notice here I brought the 4 down. I took 4 times -1, I get -4. Add the 2 together, you get -4, right? -4 times negative. Wait.
Yeah, you did.
Oh, wait, just a sec. Just a second. -4 times -1 is 4. Add them down, you get 6. 6 times -1 is -6. Add them down, you get -5. This should be -5 times -1, which is +5. Add them down, you should get -5, or I said that wrong. +5 there, -5, and you get -6. Okay.
Where do you get the 1?
The 1 from what? Here?
From x squared.
But you still need a 0?
This is
Because
your
there's no
x to the
x
4th.
power.
This is your x to the 1st, and this is your -1. So remember the key, my highest power is 5, right? So that meant I needed 6 terms. So if you look, there were 6 coefficients.
These are fun. I like
Okay.
these.
So that's synthetic substitution. All right, let's try another one. Let's try and get everybody to get this one right.
No problem.
Okay?
We need
Oh,
our
this
little
one doesn't
clicker
have any
things.
Okay. So, actually, I do have, they were registered to you type in on this one, but.
Yeah, good. Is this all the lemon stuff? I like this. Just save this for today. That would just make my life so much easier. I have like time to change things. I put a dark color underneath it.
Okay, did you get a number bigger than 10 or less than 10? Bigger than 20, less than 20? Less than. It should have been just a hair less than 20. Should have gotten an answer of 19. Okay? So, nice job. Okay, so now, real quick, what we're going to do, first of all, I'm going to get rid of this, is we're going to talk about the factor theorem. And basically, the factor theorem says that if something is a factor of it, then what happens is if I plug that number in, I get 0. Okay, that's what the factor theorem is. If it's a factor and you plug it in, you aren't going to get a remainder. And so it says, is x minus 5 a factor of x cubed minus 7x squared plus 7x plus 15? If so, then find the remaining factors of the polynomial. So we're going to use a little synthetic division here. So that's how it ties into the ones we just got done looking at. And so in this case, I'm going to divide by the opposite of negative 5. The reason why you use the opposite is because if I were to set this equal to 0, what would my solution be? It'd be 5, right? So that's what I'm going to divide by. I'm always going to divide by that opposite of that number. So let's go ahead and put 5, and then let's list our coefficients. Okay, so I have 1, negative 7, 7, 15. So let's go through and do our synthetic substitution, well, synthetic division, same thing. And let's see what we get. It's 0 here. So since it's 0, that is in fact a factor. So is it a factor? Yes. Now it says, if so, find the remaining factors. Well, this is the thing. If this is the remainder, this is gone. Now, if you remember when we did synthetic division, we would now attach x's to each of these. Okay? And so I started with x cubed, right? If I divide that by x, what power of x am I left with?
Squared.
X squared. Very good. And then this is x, and this is my constant. So really what I'm left with is x squared minus 2x minus 3. Now I want to find the remaining factors. So to find the remaining factors, we are going to factor this. Okay, so this is a 1, right? So remember how I start? What will be the first in each of these? X. Okay. 2 factors of 3 that differ by 2. What are they? 1 and 3. How do you get a negative 2 from 1 and 3? Positive 1, negative 3. Those are your 2 remaining factors. Okay. We're going to look at another one of those.
I've just gotten up for another one.
All right. Is x minus 2 a factor of x cubed minus 7x squared plus 4x plus 12? Now this is the thing. If it's not a factor, okay, you're done. You don't have to do anymore.
How do you know if it's not a factor? If it comes up to something other than 0?
Yep. So what am I going to divide by?
1.
I'm going to divide by 2. Remember, it's the solution to if that was equal to 0. So it's going to always be the opposite. So in this case, a positive 2. My coefficients are going to be what?
1, 7, 4, 12.
Okay.
Negative 7.
Yep. So let's go ahead and see if that's a factor. So is it a factor? Yep. So I throw this off, and what will my new quadratic be?
X squared.
Now, it will not always be a quadratic. The only way it will be a quadratic is if this lead term is x cubed. So now let's go ahead and factor that down. What will go in the first?
X minus 6.
X, x. 2 factors of 6. They must differ by 5. And you said 6 and 1. Why wouldn't 2 and 3 work? What do 2 and 3 differ by? 1. Okay, so it's important you get those factors of 6 straight. All right, how do you get a negative 5 from that? Negative 6 and positive 1. Nice job.
Yeah, why can't you use
Because 2 and 3 don't differ by 5. The numbers 2 and 3 differ by 1.
Oh.
They add to 5, but they don't differ by 5.
So, but,
Okay. Alrighty, so here you go. On page 355, I need you to do 8 through 26, the evens. Now, you may have a question or two tomorrow at the start of class. Remember, we're going to take another day to do this section as well. Okay, so on page 355, 8 through 26, the evens. When you